Good morning. My goal today is to give you an industry view into the path we have on AI. And this is not an easy task because by the time I finish this talk, the talk is going to be out of date with the speed of innovation and the speed of deployment that we have in this technology. And in fact, I find myself writing a new talk every month because what we are dealing with, what we are seeing in the field is constantly changing. So I have three goals with this talk. One, try to provide an overview of the current state we have in industry when it comes to the use of AI. And second, talk about some of the opportunities and the challenges we are seeing. And Missy did a great job of talking about some of these challenges in the safety critical domains. I'm going to be focusing more on the productivity settings. And the third one, which I think is the most important, is to make a call for collaboration. Because where we are right now, these problems that I'm going to be talking about and Missy talked about, they are not going to be solved by just scaling up the AI models. We need interdisciplinary approaches coming together as academics and industry to actually start working on these very key problems, because I don't think AI is going anywhere. I think it's going to be affecting our lives, and it's going to be the responsibility of you, the thought leaders, and the industry coming together and find good solutions to these upcoming problems. So with that, let's get started. Just as an overview, the latest era of AI development is kickstarted by three factors: large-scale data, compute and hardware that is optimized for neural computation, and actually basic research on architectures like transformers that made the scaling of these models possible. The combination of these discoveries started an exponential scaling up curve that many of you are familiar with. We are seeing that the size of the models are increasing, the data that goes into these models are increasing, and on benchmarks, the performance of these models keep improving. And this exponential scale-up gave us some of the frontier models that many of you are using, like ChatGPT or Gemini models. The billion-dollar question that Missy also touched on is whether that exponential scaling up is going to continue to giving us good outputs. We don't know. Whether we are going to get to this notion of artificial general intelligence, which is actually undefined in the community, that's not the point of my talk. But the point I would like to make is that even with the current state of these models are becoming a general purpose technology that we can utilize and build on top of to create various applications. And the reason I'm calling it a general purpose technology is that the kind of applications we can build with these models is endless. They can be applied to many different domains. Just to give a few examples, currently ChatGPT has around 800 million users. People are using it for all sorts of purposes. Some of them might be good, and some of them might have issues that the users may not be familiar with. But when I go to the Apple Marketplace, the top two downloaded applications are Gemini and ChatGPT. That's the reality of our world today, whether we like it or not. More than 80% of enterprises are using generative AI one way or another. In the last 3 days, we heard many examples of potential of using AI in sciences. But the application I like most in terms of understanding the current state of AI and where it's going is actually the application of these AI assistant technologies in software development through applications like GitHub Copilot, Codex models, or cloud agents. And based on some studies we've done at Microsoft Research 2 years ago at an earlier version of this technology, we have actually seen that the productivity of software engineers that are using such technologies in terms of the lines of code written is double the lines of code written by software agents that are not using these technologies. Again, we need deeper research to really quantify productivity, measure it, but these are early indications of, and also qualitative examples why these technologies are becoming a cornerstone of software development today. These are just some examples of AI entering our real world. At the same time, we are seeing that this transformation of putting AI into the real world is not going to be a straightforward one. So what is happening in industry is that all of these use cases are creating a race, an explosion of investment that is going into data centers all over the world. And what comes with this investment is very high expectations. All of these companies are expecting that they are going to be getting exponential return of investment from their investments. And this is putting a lot of pressure in terms of putting and deploying these technologies into the world. However, there is this MIT Tech Review article that came a month ago that was actually like a cold shower over the industry in terms of the path of AI. So what this MIT Tech Review article showed is that in enterprise deployment scenarios of generative AI, 95% of them fail to deliver the expected return of investment. In fact, only 5% of the enterprise applications ends up getting deployed to create this return of investment. So this leaves us as of November 2025. Again, this talk will change next month. We'll see what the topic of that talk is going to be. But as of November 2025, we are in a generative AI divide. On one side, we have big investments, big expectations, a rush to be able to get exponential return of investment from these technologies. And on the other side, we are seeing the shortcomings, the limitations in terms of getting high return of investment from these technologies. That is where we are. That's where there is a notion of confusion that we are seeing across the industry. So one thing we can do at a time of confusion is look at the past. And if you really believe that AI is a general purpose technology, can we actually look at the past examples of general purpose technology entering the world and try to learn something about how to get this right? So one of the examples I have been reading, I'm not a historian, I'm sure there are historians in the room that know about this topic so much more than I do, but based on my limiting reading, one of the parallels I find very interesting is the transition of enterprises from steam power to electricity, as considering electricity to be a general purpose technology. And although that technology existed, the transformational value from that technology actually took decades to get it right. So the question is, are there lessons we can learn from the past in terms of creating this transformational value from these generative AI applications in our world? So I like to highlight two lessons that resonate with me in terms of the current state of AI. One of them is that we cannot expect transformational value by incrementally integrating these technologies into our world. We need to start thinking about redesigning our workflows and processes with this technology at its center. And the second lesson is that we are not going to get there by just investing in a single technique like scaling up these models. We need to start thinking about the computational stack, the new programming stack that is coming up with these models at its core, and how to complement it with techniques from HCI, from systems, from verification, and other methods to be able to understand and address the shortcomings of this technology. So if we look at the many uses of generative AI today, they are in the form of chatbots. This is what the copilots are. This is what ChatGPT is. I would actually consider these scenarios to be an incremental use of generative AI. Why? They are sitting on the side. We can ask them questions. They can tell us how to do something, but they cannot do anything for us. But I believe the reason there is so much excitement around AI agents is that AI agents is a much more transformational way of using AI technologies in our daily lives. So what is an AI agent? An AI agent is a computational entity that can take a complex task and getting done by taking actions in the world. And the way AI agents work is that they take the task, they plan about what is the next best action to take to get us closer to the goal that we are trying to achieve, take that action, observe the effect of that action in the world, use that observation to be able to plan for the next step. And the reason AI agents matter for us at the current state of AI is that they are about getting things done, which is a much more transformational value than just telling us what to do. By the way, the topic of AI agents is not new. Like many things are not new, like neural networks are not new. In fact, 15 years ago during my PhD work, I worked with Barbara Gross, who is in the audience today. She's a member of the society on this very same problem. And as I said before, my favorite domain to observe the real-world integration of AI is software engineering. So starting from last year, we are actually seeing that the deployment scenarios of generative AI are switching from these code completion agents to AI agents that are doing tasks on people's behalf. And in fact, what is happening is that the IDEs, the development environments that software engineers use, are actually changing, are being redesigned in a way that is much more compatible with this agentic technology. It's a part of the more transformational way we are thinking about this technology. So the point I would like to make today is that if we want to make this prospect of agents possible, we are not going to get there by just prompting the frontier models. We need to approach this as a software engineering problem. What is the computational stack that we can build that have these models at its center, but complemented with techniques that are to be created or known in computer science to make it reliable, to make it high performant, to address the limitations we have these models? So my team at Microsoft Research has been working on this problem. We have been building agents. We have been thinking about this agentic stack of complementary approaches to make this promise possible. Earlier in this year, we have created Magentic UI as an experimental test bed to create agents that can do things on digital environments on your behalf. And what you're seeing here is the agents in action, making reservations, booking travel. And one of the things that is very important that also aligns with Missy's talk earlier is that we have actually spent a lot of time to create this transparency and accountability layer between the agents and the human so that the human is able to observe what the agent is doing, has the capability of stopping it and intervening it when the human is not OK with what the agent is doing. And I cannot emphasize it enough how important it is to really invest in these interaction techniques in addition to all the work that's happening on models to be able to get such agents right. I want to quickly mention a few things that we are working on to make this agentic stack possible. As I said earlier, even the frontier models of today are not actually a good fit for the needs of these agentic systems. These agents cannot be powered with language models, but what is happening around reasoning models right now, large reasoning models that are able to decompose larger tasks into smaller actions, seems to be a promising path that we are exploring in terms of giving decision-making capabilities into these agents. But also, in real-world deployment, models need to be fast. They need to be efficient. If we are going to be using these agents on our computers so that they don't leak information about us, they need to be small enough to be hosted on our machines. And that's why, although many frontier labs are going for larger and larger models, we have been actually investing in small models that can be deployed on devices that do not require any cloud access or carbon emissions. And we have been actually getting really good results with the family of models we are creating around the Phi family. But the other trick that we are using in terms of creating these agentic systems is investing in multi-agent system techniques from the past. If we want to master a domain, again, it is not enough just to prompt a frontier model. But we can really understand the capabilities needed to be able to master that domain, create specialized agents that can be deployed together in collaboration of agents and collaboration of people to be able to get these tasks done. And we can even create specialized agents that does the verification, that does the control, that does the hallucination checks around the work that is happening. And I mentioned this before, but it is very important that we are also working on the interaction side and the human oversight as well. Before starting my AI lab a few years ago, I actually spent almost a decade at Microsoft working on responsible AI, worked on tools, best practices, education, worked across the company to actually make responsible AI possible, and even wrote a first version of a responsible AI standard that is active today at Microsoft for all AI projects. And one of the lessons we have learned from working on responsible AI is that the work on responsible AI is never done. That's the hard thing about it. With every changing version of AI technologies, we have to do the work on responsible AI again and again and again to understand the limitations and come up with new mitigation techniques. This is true for agents of today. And in fact, when we build our agents, we use it for testing and understanding of the limitations of these technologies. And we are seeing that AI agents are changing the risk surface when it comes to having these AI systems in the world. I want to give an example of what we are seeing with these AI agents today. A few months ago, I was testing the agents that we are creating, and I gave the agent, in my opinion, a very simple task. I said, go to New York Times, find a crossword puzzle, and complete it for me. The agent went to a search engine, typed for New York Times, found the right link, followed the link, went to the right web page. But there, the real world happened. There was a pop-up window. The pop-up window asked for my credentials to be able to enter the New York Times site. The agent did not have my credentials, but again, they can explore new ways of getting things done. So what the agent actually did is realizing that there's actually another link on that pop-up window. It could reset my password instead. Because why? The agent has access to my email. It can do that. It can plan. And it actually took the steps to reset my password. But it did not stop there. When the agent realized that it couldn't do something, it went to Mechanical Turk and tried to hire a person to do it instead. When it was trying to find some document that it was no longer available on the internet, the agent read that it could actually write an email to the government asking for that information. So the point I would like to make is that as we are moving to these autonomous or human-in-the-loop autonomous technologies, there are new risks that we need to start, measure, and mitigate very carefully. This is kind of an overview on where we are in AI technologies today, but I want to take the last 3 minutes to talk about where I believe we are going next, because that is even more important than the risks I talked about so far. So far, we have been building AI agents to be either monolithic entities or to be entities that are interacting with people. But this will change. We are already seeing that agents that are created by different companies or individuals are starting to connect and communicate and collaborate. And what this means is really starting to think about a new ecosystem. A new connected entity that will emerge as these agents start working together. And I don't know why the stars are moving. I'm not pressing anything. Maybe my agent decided that it was time. Let me see. OK, sorry about this. But what we are really seeing is that as these agents start connecting to each other, they will start creating new interactions. They will start creating new ways of getting things done. And they are going to create new ecosystems that will turn into marketplaces and ways of getting things done. Just imagine for a second that the assistant you have on your computer is going to be able to send a message to my agent to schedule a meeting. But it's not going to stop there. There are going to be agents representing sellers and service providers and information providers. And these agents are going to start interacting with each other to really control how we buy things, how we access information, and become the interface to technology. This is not a speculation. This is what's happening today with ChatGPT, starting to incorporate some of the third-party agents already into the ChatGPT ecosystem. So the point I would like to make is that this is going to change things. This is going to change things in very serious ways. When we are thinking about ecosystems, ecosystems create new market mechanisms. They create new economic models. And they change power structures. Who controls ecosystems? They control power. They control what people buy, what people see, and how they could be manipulated to make more money. And again, this is happening. It is not a speculation about the future. The promising side is that we have seen this in the past. We have seen the emergence of ecosystems in the past. And we did not get it right, but this might be an opportunity to get it right this time because maybe we can learn lessons from the past. So what happened at the emergence of internet? There was a lot of promise. We thought that people would be connected to each other. There would be democratization of information. But what ended up happening? We got new economical models. We get the attention economy. Our attention and cognition got commercialized by technology companies. Small number of companies started controlling what we buy, what we see. We are still dealing with the ramifications of those decisions. So the question is, how can we work together to get the agentic economy right? Because this is going to happen. We know this is going to happen. We have research showing that this is going to happen. And we have an opportunity to create a different kind of an economic model. But if we don't get it right, there is also dangers. There could be new monopolies. The income gap and the power gap may increase. And the consequences of that could be substantial for our society. So that, if you're going to remember one thing from this talk, that is what I would like you to remember. So I'm going to finish with some quick remarks about where I think we need to be doing some work on together. The first is a computer science conjecture. As the last two, hopefully I conveyed it and Missy definitely conveyed it, we are not going to get to the reliable and the safe AI systems we want to get to by just scaling up the models we have. We need to bring together complementary technologies, techniques that have been worked on for the decades in the past. AI is not a new field, but we need to translate them to this new world and new computing paradigm that we are working on. In fact, I think at this current moment, there is just such a big opportunity to start bringing these pieces together. Verification, systems, formal proofs, blockchain, many things will have some way of integrating into this new stack. But the most important thing is a collaboration conjecture, an academic conjecture. Many of the issues I talked about today are not AI problems. They are not computer science problems. How these technologies are going to change the way we live is not a computer science problem. How they are going to change the way we work is not a computer science problem. These marketplaces, power structures, they are not necessarily computer science problems alone. So how do we enable multidisciplinary research to come together and actually create clarity as these systems are being developed today? And one of my personal complaints about the AI world is not taking responsibility. In many ways, we are creating these technologies, but not really expecting to understand what they do. Not expect to understand the impact they create in the world. There is a notion of fatalism that is going on in the frontier labs. It's like, we have to do this. There is no way for us to know what we are doing. But once we get there, we'll figure out all of the bad things that are happening with that. I don't think that is responsibility, and we need to change that. So the last point is that the world is going to change, whether we like it or not. We are already seeing this change. I think as humans, we are going to realize what it's going to be a human in an AI world. We are going to discover what is unique about us, what is special about us, how to use this technology. But there is actually a big responsibility on all of us to get this right for our children and for the next generations to come. Thank you very much.
Thank you, AJ. Please stay. I know that there will be questions. These have been two stimulating, exciting talks. Rich, I see your hand back there. Please state your name and where you're from first.
Yeah, Rich Schifrin, Indiana University. Thank you very much. I've read numerous research articles identifying problems with current AI and predicting where things are going. People like you are very, very creative and clever. As a result, pretty much every time someone makes a prediction that AI can't do something, then a little while later, it does it. I want to ask, how confident are you or anyone, should you be or anyone be, that you can predict where AI is going to be a few years from now?
I have been wrong on this question so many times in the past. In fact, I was one of the first scientists from the Microsoft side that gained access to a model called DV3 that later became GPT-4. This is before there was a ChatGPT in the world. And with all of its limitations, when I first started interacting with this model in the summer of 2022, I was blown away. And I said myself, you were so wrong about what you thought this technology would go. So I learned to be humble. I am making educated guesses based on some of the evidences we are seeing. For example, the fact that ChatGPT is already incorporating some of these agents into it, the fact that there are emerging protocols like MCP and A2A are giving us good signals to predict what is going to come. But do I feel confident that I'm able to predict whatever is coming? Not at all. But we also cannot say, I'm done. I don't have a responsibility here because I cannot predict the future. We have to be in it. We have to be building things with it. We have to be understanding the limitations. We have to be investing in complementary approaches so that whichever way this path goes, we are prepared to take it on.
Hi.
Oh, thank you.
Hi, Richard Lenski, Michigan State University. I found the first talk sort of scary, and in some ways I would say I almost found your talk a little scarier, in the sense of the optimism that it'll work out well. And it seems to me, I'm wondering to what extent you see evidence of sort of a scam ecosystem emerging. It seems to me that there'll be a huge advantage to people who really are understanding some of the risks, and many other people, there seems like a huge opportunity to take advantage of people with agents that are nominally working on their behalf, but actually have, because of this emerging ecosystem, there are parasites as part of the natural world. It seems to me they will emerge within these systems very naturally and be very difficult to keep up with.
So first of all, I'm glad you got scared because that was my goal. But again, you know, yes, we are going to reflect on the current state of technology. What matters more is what to do with it. Because, again, I don't want to be in this state of fatalism where we say, oh my God, this is happening, it's going to be great. How do I find a bunker to hide under? The question is really like, what are we going to do about it? Because the people in this room have actually a lot of influence to tell people that there is work to be done. We know there are dangers. In the past, we have worked really hard on mitigating such dangers. In many cases, we've been successful. In some cases, we missed things. The question is, how do we learn from the past? How do we learn from social media? How do we learn about the attention economy to really get it right next time? So my reason of giving this talk is not to scare you, maybe a little, but it is really create an action to really think us together what we are going to do about it. I think there are a lot of things that can be done. The research labs, at least under Microsoft Research, the New York lab, there's a nice paper they have written about possible business models, the upsides and downsides of each. We are now thinking about how to change the existing protocols to go for much more of a balanced, two-sided potential marketplace rather than a monopoly. These are things we can, with our economist friends, we are starting to look into and really bring a scientific lens into.
Thank you. Alejandro de Avila from Oaxaca, Mexico. What is happening in China? And what would be the ethical implications?
China is emerging as the second powerhouse when it comes to AI development. They have the talent, they have the investments to get it right. And in fact, the DeepSeek moment, I don't know if you heard about it, the Chinese research lab creating an open source model that was able to match the performance of the O1 models from OpenAI. That was actually like a big wake-up moment for everybody. So it is fine. I think all over the world needs to innovate on this big technology. The question is, how do we innovate together? One of the things I am a bit scared about is, using China as a way to create this competition feeling that basically says we need to do everything super fast because China is coming. That's going to create a lot of other problems for us. So I think the question really is, how do we continue innovating on this, work with countries around the world, because there's good intellect everywhere, and actually do it responsibly. I think that is the line that we will need to walk. It's gonna be an important line to walk, but I think that's the responsibility. But China is coming strong. They are doing a lot of good innovation. I think one of the things that is a little bit disappointing is that the competition is pushing many parties, even the frontier labs in the United States and definitely China, not to talk about their progress anymore. When DeepSeek came out, they published a beautiful paper that actually brought a lot of academics into the topic of reasoning models. That was a great thing. Since then, they have been completely quiet. So I think we also need to think about how to ensure this collaboration. How do we ensure that wherever the work is getting done, academia or industry, we are sharing, we are publishing, we are openly talking about our work, which doesn't seem to be the trend right now, and that's a bit disappointing.
I'm going to take liberty of asking you a follow-up question, because you addressed in your own remarks this fatalism, as you called it, on the part of academics, corporate individuals, sort of laying down and sort of waiting for it all to wash over us and we'll figure it out. And then Rich Lenski asked the question about his fears, and your answer was very, very useful in that you said, in certain model systems, like at Microsoft, where you have genuine collaboration and where you have an interest on the part of the AI developers to understand the real human needs and anxieties, this is one thing. How can we have that infection spread to other realms when, as you just said, there is so much now intense competition between corporations and entities for who's going to build the best, the fastest, or ostensibly the best? In other words, who's going to build the best generalized intelligence model, and that increasingly will have been developed in secret? How can we potentially still open this up so that academics from various human sciences and others can be interposed or introduced into these systems as true collaborators to try to make this work better for humanity as we go forward?
You are just touching on the most central problem we are facing right now. How do we collaborate instead of competing? Of course, industry is going to compete. That's what it is for. But at the end of it, if we don't get it right, everybody is going to lose. This is not going to be like there's going to be one winner and everything is going to be good. So the question is, how do we create the mechanisms for conversation, collaboration? How do we make sure that our academic exchange on these topics do not happen on Twitter, but it happens in much more depth? I think I would pose this question back to you, actually, if I may. What is the purpose of this society in terms of bringing these parties together? Because this is such a prestigious society. People would come for you, right? How do we ensure that national academies, this society, act as a partner? But eventually, we cannot really underestimate the role of governments and regulation in this space. When we worked on responsible AI, of course, working at Microsoft has some benefits that we don't do much work on attention economy, and that's kind of a benefit that we were encouraged to do this work. But things really became real when regulation came up, right? So I think engaging with the policymakers, explaining them the state, the problems, the challenges ahead, and really be active in terms of getting that regulation, government participation in these topics is going to be very important.
Great. Please join me in thanking AJ before we go to our break. Absolutely stimulating. I think you've thrown down the gauntlet for us. So we will see what we can do. Thank you very, very much.